Hey guys, Mr. Marone here. Welcome back. We are talking G.co.C.11 today. We're going to lay all the foundation, and this is all about quadrilaterals. So we're going to define really our focus for the section, mainly focusing around the parallelogram and all of the figures that fit into that family. So what we're going to do to define these is we're going to use an example, and I'm going to kind of flip back and forth here. So to give you an example, here is what a parallelogram looks like. And just as a reminder for thinking back to previous years, parallelograms have two sets of parallel sides, and those sides are also congruent to each other. Okay, so we've got a lot of stuff here, and we're going to come back to this diagram as we go. But overall, just to get you a definition, a parallelogram is a quadrilateral with two sets of parallel sides. Okay, remembering that the double vertical lines indicates parallel, and these two are also opposite parallel sides. So the sides are across from each other. That's a big key here. Now, from there, we have three special parallelograms. All of these three, the rectangle, the rhombus, and the square, hold to the same exact definitions of parallelogram. They're just special cases. A rectangle is a parallelogram with four congruent angles. So we're going to have four congruent angles. And we all know the rectangle, all four sides of a rectangle, the angles are 90 degrees inside of it, with, once again, all the same exact pieces of our parallelogram. Now, a rhombus is a parallelogram, only its special thing is that it has four congruent sides. Okay? So it's a parallelogram with four congruent sides. And then we have the square, which is really kind of the perfect figure in the quadrilateral world. And a square is both a rhombus and a rectangle. And what that means is it is a parallelogram with four congruent sides, like a rhombus, and four congruent angles, like a rectangle. So it's got congruency all over the place. They are great to work with. So below this, you're going to have all of these properties. We've got this whole big list of properties here, and I'm just going to draw arrows across where all of these count. So we're going to start with the parallelogram. We said before from our picture that our opposite sides were congruent. Okay, so going to our picture here, we have our two sets of opposite sides that are congruent. And that's going to be true for all of ours. We also know that our opposite angles will also be congruent. Okay, so if I flip back over to my parallelogram, that means that this angle and this angle are congruent, and that this angle and this angle are congruent. And once again, that's true for all of these. We also have this other thing that consecutive angles are supplementary. They equal 180 degrees for all of these. So going to our diagram here, that means that angle D plus angle C equals 180 degrees. And that also means that angle A plus angle B is 180. And we could keep going with A and D and with B and C as well. But the consecutive angles in a row, not opposite across the figure from each other, the consecutive angles will be supplementary. And once again, that's true for all of them. And our last one that we can talk about is, you saw there were two red lines in my figure that we refer to as diagonals. And in all parallelograms, the diagonals bisect each other. And that's true for all of these figures. So if we go to our picture here, that means that we'll have this intersection point E. That means that DE is congruent to EB, and that tells me that AE is congruent to EC. So you can tell there's a lot of stuff going on in these figures, which is good. There's a lot of things for us to work with. Now, let's fill in the rest of this table just to make sure we cover all of our bases here. And we're going to have to add a couple. You've got space on your paper, but I'm going to have to add a couple to this image here. So when we look at rectangles, we know that rectangles have 4 right angles, right? 4 congruent angles. That is also true of our square. So our square will have 4 right angles as well. The other thing that's true about rectangles is that our diagonals are congruent to each other. And once again, a square is just a rectangle, so our diagonals are congruent in that figure as well. And that about rounds out what a rectangle's specialties are. So it's got all 4 of these properties of a parallelogram plus those extra 2. The rhombus has 2 extras as well. Our rhombus has perpendicular diagonals. So if we were to use our example here, I know this is a parallelogram, but in a rhombus, we've got right angles in here. So we've got 4 perpendicular lines which create 4 right angles here. So I've got that extra angle that that gives me right angles in there, and it makes me have 4 right triangles inside of my rhombus. Okay, so that's one. And that will also be true about our square, since the square is also just a rhombus. And then there's one other one that we have to add in. With a rhombus, we said that it has 4 congruent sides. And that will be true of our square as well. So as you can tell, there's a lot of stuff that goes on with these figures. A lot of things that we can use to our advantage. And what we're going to do on the next couple pages is just look at some examples of these. So at each one, starting with our first one here, we're going to have a parallelogram and a rhombus. So use that chart you just created and see if you can find the values for x and y. Under each one, after I've come back from pausing the video, I will have not only the answer but also the reason behind why we can say the answer that we have. So go ahead and try these. I'll pause the video and then we'll come back and see the answers. Okay, welcome back. So the first two, all 6 are filled in. We're going to look at the first 2 first. So if you notice, I marked a couple things up in our parallelogram. To find x, we've got parallel lines AD and BC cut by this transversal here, our diagonal. So that's creating alternate interior angles. That allows me to say that angle DAC and BCA are both 13 degrees. And to get y equals 3.2, in a parallelogram, our diagonals are bisected. So E is really the midpoint of BD. If BE is 3.2, ED will be the same thing. And you'll start to see these patterns come out throughout the review of the rest of these problems. So with a rhombus, remember we have 4 congruent sides. That allows me to say that AB is 12 centimeters, since BC was 12 centimeters. And then to find angle Y, in a rhombus, these diagonals bisect the angles. That means that my 2 angles up the top will be 68 degrees each. The angles are always bisected when we have a rhombus. So that allowed me to say that Y was 68. In 3, we've got a square. So remember, we've got right angles in the middle. We've got all 4 congruent sides. So that allows me to say that X is 15 centimeters. It matches the other side lengths. And Y, because it is a central angle and we have perpendicular diagonals in a square, will be 90 degrees. With rectangle ABCD, all of our 4 angles on the outside are right angles. So that means that X and 71 together equal 90 degrees. Subtracting 71 from 90 gave me 19 degrees. To get Y, I had to use Pythagorean theorem. You notice I highlighted that AB and BC were the 2 legs of the right triangle at 5 and 12. We were looking for Y, which was 13. So what we're going to have here is Pythagorean theorem, and when we solve out, we end up with a 13 centimeter measure here. Okay, using Pythagorean theorem, squaring the 2 legs, and then using a square root. For 5 and 6, in 5 my rhombus has a full diagonal of 12 centimeters, and diagonals are bisected. That tells me that AE and EC are both 6. And then with my angle BCD of 68 degrees, remember in a rhombus the angles are bisected, so each angle would be 34 degrees. And then alternate interior angles give me that BCE and DAE are 34 degrees. And then to finish it up with number 6, with parallelogram ABCD, X we had alternate interior angles with that AC diagonal as our transversal. And then to find y, I used the triangle on the left-hand side, having 36 and 62. And I found that my third angle was 82 degrees, and then I used alternate interior angles to get angle EDC, as was asked for y. So give it a try in your homework tonight. See if you can solve these problems, and we will review them in class tomorrow as we look at some proofs behind our quadrilaterals.